Okay, so like I said, please fill out the attendance tracker form. Today we're going to be going over sedimentary rocks for 3.1.3. Let me pull up the PowerPoint. We have one more day until Thanksgiving break, and then we get a week off. So let's trek through this and get to next week where we can hopefully rest and relax and enjoy the company of your family. So today, 3.1.1, which is all on sedimentary rocks. Today is November the 18th for A Day, and for B Day, it's November the 19th. So before class today, you should have done 2.4, the Unit 2 post-exam reflection, and 3.1.1, the video lecture on sedimentary rocks, as well as the quiz and discussion board for the peer instruction. Which brings us to today, where y'all will be doing a 3.1.1 sedimentary rocks activity. And basically the premise of this activity is for you to look at different rock samples online and to identify what type of rocks they are. So here in just a second, we're going to walk through what are the differences in sedimentary rocks so that you'll know what you're looking at. So on a normal year, we would have these rocks actually set up around the room where you would be able to touch them and feel them and look very closely at them. So the nature of this assignment is a little bit altered since you're looking at rocks online, which is a very different experience. But there is a website that you'll use that I'll show you how to use here in just a second. But like I said, basically the premise of today is that you are looking at rocks and trying to identify what type of sedimentary rock it is. So let's talk through sedimentary rocks for just a minute, and then I will explain a little bit more in depth your assignment, and then I'll let you get to work. So sedimentary rocks are my favorite type of rocks, which sounds kind of weird. But like we did earlier in the year, there's three main groups of rocks. You have igneous rocks, sedimentary rocks, and metamorphic rocks. Most of the rocks that you're going to see at the surface of the earth are sedimentary. And that's just because sedimentary rocks are rocks that are at the surface. Metamorphic rocks are going to be deep in the mantle, deep in the crust. And then igneous rocks are going to be out of magma. And most of the times these are going to be near plate boundaries or volcanoes. And so, like I was saying, most of the rocks that you see on a normal day are going to be sedimentary rocks made out of sediment from other rocks. So here on this rock cycle, you can see something called sediment. And sediment is anything that is just tiny, tiny fragments of other rocks. So you can see all of these green lines pointing to this sediment. Sometimes you might call this dirt. Sometimes you might see this running in streams or on the bottom of stream beds or as dust in the air. That is sediment. And like I was saying, it comes from little tiny rocks, little tiny fragments of all of these other types of rocks. When I think of sediment, and this is because I grew up in Alabama, but when I think of sediment, I think of the like red dirt. Lots of time you might see red or gray or these tan colored rocks, and that is going to be a sedimentary rock because it's made out of sediment. We've talked about this like at the very beginning of the year, but rock color is based off of rock material. So a rock that is more red in color is going to have more silica in it, the element silica. And then rocks that are metamorphic or igneous are going to have more like carbon as the sediment in it, which is black. Or trying to think through my elements. I used to have an element poster in my room that I don't have anymore. But most of these sediment rocks are going to be made out of silica, which is, or a lot of oxygen, which is what makes it red. So the way that these sedimentary rocks are formed, and you watch this in your video, is through compaction and cementation. Compaction is what it sounds like. It's when all of these sediments are compacted together so much as to form a rock. And then cementation is basically the same thing, just getting compacted together. And it depends on if that's chemical or if it is just physical. So that brings us to our next point of sedimentary rocks can be clastic or they can be non-clastic. A clastic rock is going to be where you can see the grains. So like over here, you can see these pebbles, you can see these bigger chunks. If you were able to zoom in on this picture, this would look like sandpaper, also sandpaper, and then shale, you can see the different layers. And so once again, these clastic rocks, you can see how they are formed together. I like looking at conglomerates. Some background information on me. My dad is a civil engineer. He has spent much of his life researching, super exciting, researching pavement or asphalt, the things that roads are made out of. And so a lot of times we make pavement or roads, we make out of a conglomerate mix. So I bet you've never thought of that before, but things like our roadways and our infrastructure a lot of the times is built out of some composition of rocks, which we could call a conglomerate. So clastic rocks are formed together, and then non-clastic rocks, so these examples over here, are formed from chemical or biologic processes. So if you can see a seashell in the sedimentary rock, that is non-clastic or biological. Or if you can see here you have halite, which is formed from just chemical processes happening over and over again. Most of the time these are in the ocean. So here limestone, an example of how we form limestone is from like seashells decomposing over time and then getting compacted. And so you're going to find limestone deeper in the earth just based off of that biologic material of those seashells, which seashells are formed by biology. And so that's really the main difference. Is clastic is a bunch of little tiny sediments formed together, and then non-clastic rocks are formed from a chemical or a biologic process. And so really when you're looking at these, if you can see grains, it's clastic, and if you can't see grains, it is non-clastic. So we have, for your assignment today, you're going to be looking at 9 different rock types, and you're going to be making observations on color and on what it's made out of, the grain size, the texture, and where you think that rock was. So was it in a riverbed or was it in the bottom of the ocean? And then you're going to come up with the rock name, which I will show you the website for that here in just a second. But as we're looking at these sedimentary rocks, we can notice color. They're most likely to be red, gray, or brown. And this is revealing, like I was just telling you, what type of mineral is in it, or sometimes where it was formed. So if it was formed in the bottom of the ocean, it's probably going to be a different color based off of the things that are able to factor into it than if it was formed on land. And then texture. So texture is what size grains are there. So think about this for a second. You can have really big sediment or you can have really small sediment. This is due to how far it has traveled. So if you have, let's say, a metamorphic rock and it breaks in half, and then it breaks in half again, and it breaks in half again, that is how you form sediments. But if that rock kept traveling, let's say it's getting picked up by wind or taken down a stream or even picked up by a person or an animal, the more it's moved, the smaller that sediment's going to get. So when we talk about texture, are the grain sizes really, really small or are they medium size? And the way that this texture changes is based off of what type of erosion has happened. For example, on that one is that, let's say a pebble is moving down a stream. Okay, that pebble is rolling and moving and getting rounded because it's basically like just a smoother. The more it moves, the more that it's hit by water, it's going to get smoother and smoother. So you could say that that texture is smooth, but if it has just recently broken off of something and hasn't gotten the chance to smooth out, then you would say that that texture is rougher. So when we're looking at texture, we're looking at grain sizes, sorting. So are there a lot of different sizes or just a few? And rounding. So is it rounded or is it angular or is it somewhere in between? So let's look at a couple pictures. This first picture is showing the color. So terrestrial means land. So most of these land sediment rocks are going to be brown or red or somewhere in this scale. Remember, just based off of how much oxygen, how much silica is present. And then sedimentary rocks in the ocean or shallow and circulating water are going to be grayish or greenish. And then if it's super deep in the ocean or the rock or the water isn't moving, it's going to be black. And all of this is based off of how much oxygen is present. Which makes sense because if it's closer to the surface, it has a chance to oxidize more than if it's way, way, way deep in the ocean. So if you're a big chemistry nerd, I am not. I hardly know what I'm talking about when I'm talking about chemistry, but the oxidation reactions that happen in chemistry is kind of what's happening to these rocks. So the more that it's oxidized or the more oxygen that's present, it's going to get even more red. An example of this is going to be rust. Just in the different science world, if something is rusted, it becomes more red. But anyways, like I was saying, that's chemistry. I'm not good at chemistry, so we'll keep moving. So the next thing is this classification system, which is basically what you're working on today. Like I said, you're going to sort out 9 rocks, but here is a great little rock identification chart for you to look at as you are working. And so like we said, clastic or non-clastic is based off of, is it a conglomerate or a composition of lots of other tiny little rocks, or was it chemically and organically or biologically formed? So next we're looking at the grain size. Is it big? Is it small? Looking at the composition, so what is it made out of? Quartz, you can probably think of quartz as being like that clear crystal-looking rock. Feldspar is most of the time a pinkish-colored rock. Clay minerals, those are red or tan based off of what color the clay is. And so most of the times these all mix together. The white, the pink, and the red are going to cause, obviously, a red or a pink or a white, not white, rock. So then we can look at the fragments. Are the fragments rounded or are they angular? Are they fine? Are they coarse? And then based off of these, that's going to tell you what the rock is. So it's a conglomerate if it has really big pieces in it. It's a breccia if it has smaller pieces in it. It's a sandstone if it looks like sand. It's a siltstone if it has layers, and then it's shale if it has more distinct layers. So that's all clastic rocks. And then chemically or organically, biologically formed rocks. Does it look like a crystal? Does it look bioclastic, which means like a bunch of biologic material pressed together? And we'll look at a picture of that in just a second. But you're looking basically, these chemically or biologically formed rocks are going to look way more like crystals and way more like seashells. And so kind of that, as well as not being able to see the grains, is the biggest way to tell those two apart. So next, based off of sorting, here's a diagram to show sorting. Is it well sorted, meaning all of the pieces are relatively the same size? Is it moderately sorted, meaning it's about half and half? It's moderately sorted, it's somewhere in between these two. And then poorly sorted means there's really, really big pieces and then really, really small pieces, and that it wasn't obviously sorted out. And then rounding, like I said, the more that a sediment moves, the rounder it's going to get. So this is a sediment that is just broken, and then the more that it travels through wind or through rain or through just water flow, the more rounded it's going to get. So you can tell a lot based off of the shape of the sediments. And then, like I was just saying, the transportation of the sediments is going to tell you how far it's come and what type of things that it's been eroding on top of. So that's a good chart. And then, yeah, so the more sorted that it gets, it's going to become a different rock. And I know that that's just a lot of information. You don't necessarily have to know every single thing about sedimentary rocks. That would be a lot. I think when I was in college, I took like a month just on sedimentary rocks alone. And I had this big, big, big quiz where they laid out probably 100 rocks, and I had to name all of them, which was very interesting. I can remember flying home for Thanksgiving break, and on my phone, I was studying rocks, and I was just thinking, wow, these people next to me must think I'm just like a nerd because I'm studying rocks on an airplane. But I think I got 100 on that test, which was great. But anyways, you don't need to know the name of every single rock. You just need to know what makes these sedimentary rocks different. So like we've said, texture, color, the roundedness of the sediment, how sorted it is, that's what makes all of this different. So for your assignment today, you are going to be coming to this website and you are going to label 9 of these. So there's 12 of them to do. You are going to label 9 of them. So let's pick one to do. So, okay. So here is a sedimentary rock. It's pretty light in color. If we could look closer, we could see that these are a lot of shell or bone fragments. So these are tiny, tiny pieces of shells, and they have been compacted and cemented together to form this rock. So we can come down here and know that this is biologic because this is made out of shells, which I know is hard for you to tell since it's a picture and you can't really see it up close. So we don't care about the grain size if it's biologic. And we can read through these and say organic material, calcite, microskeletal. Okay, so we're getting closer. We know it's microskeletal. And almost entirely shell and skeletal fragments. It is almost entirely shell and skeletal fragments. Calcite, no. So this is almost entirely shell or skeletal fragments. And so that's called coquina. So then you're going to hit grade. And it says up here, which you probably can't see, it says, congratulations, texture, grain size, composition, and rock type were correctly identified. So you're going to do that for 9 rocks. And let me go back to my PowerPoint. And you're going to fill out this table for 9 rocks. Okay. Like here, that's that coquina. And then here is another example. This is sandstone. If you could hold this and look at it really up close, it looks like a bunch of sand. And that's how we would identify it. So next class, which for y'all is on Friday, is stratigraphic principles and relative time. So this one is split into two classes, but during class one, we're going to be looking at stratigraphic principles. So before class, you have these 3 assignments to do. And so all in all, your assignment for today is number 1, the rocks classification, and then number 2, number 3, and number 4 are these 3 assignments. So all 4 of these things are due on, I guess, Thursday night before your Friday class. Or if you're B-Day, then it's due the day before your next class, which is going to be Sunday night. And this is what you need to do before your next class. If you at any point have questions on anything that I've said, or you need help identifying rocks or doing your assignment, please reach out to me by email or by remind, or you can stay on this meeting. But if you have done your attendance tracker form and you don't have any questions, you are free to go. I hope you'll have a lovely Wednesday, and I will see you on Friday.